It is an honor for me to have Gabriel Ahlfeldt speak to us on the plenary session. Gabriel is a professor for econometrics in Berlin. His contributions, I'm sure I was pretty fascinated because most of the papers I saw presented had one or two quotes to Gabriel's work, so I'm pretty sure most of you know about his work. His contributions have been to spatial quantitative economics. I am personally acquainted with his transport economics work and also urban economics work. I'm sure there are many other areas of interest. I would like to share with you sort of the process, how we work at inviting people for the plenary session. Is always we start half a year early. And it is usually quite a time-consuming process to work out who can we invite. With Gabriel, there was not much of a debate. Gabriel, and the reason is twofold. One thing I personally, and I think our whole institute admires, we do a lot of applied work. And we are also fully aware of the fact that not all applied work can go to the econometrica and to the top journals. Sometimes you just do practical work. But his approach in work is something that I find very fascinating, because it sounds really simple and it is so difficult to do. So the recipe to me is always the same, you know. Start from theory, find good data, make an argument that credibly identifies a parameter of interest, use the parameter of interest in a fully fledged economic general equilibrium model to find out and to make a statement of relevance. And I think this is something very impressive, something I also envy Gabriel a little bit for being able to do this in this way. And the second thing was that Gabriel is also an extremely, I don't know whether you have visited his homepage, but he was extremely helpful for us when we said, we would like to play around a little bit with spatial quantitative economics, because his homepage was the one where we finally found the documentation for a model where you can download all the stuff. So he's incredibly willing to share that, his experience and his expertise in the field. So we thought, yes, this is the guy to go for. So Gabriel, it's an honor and a pleasure.
Thank you so much. That was a very, very nice introduction. I guess a little bit too much of credit here, right? But let's see how many interesting parameters we have today that we can use in the model. It's a bold title, Geography of Life. It's one of the more ambitious projects I've been working on recently. It's joint work with my co-author, Daniel Sturm, PhD student, Katerina, now on the job market, and our man on the ground of Copenhagen is Izmir. So let me, provide some context to this bold title. I think it should be a paper that is easy to relate to, because it concerns life, or certain aspects of life that concern all of us. One of these aspects is aging. We all get older, that's quite inevitable. And the other is the circumstance of life, which are basically family circumstances. So think of family changes in your life, when you marry, when you move together, when you have children, eventually you may divorce, separate, your spouse may die. All of this changes dramatically how you think about life. And economists have looked actually at how these seminal life events and also how aging affects economic choices. But one area where we know surprisingly little is how these two features of life affect location choices. And that is maybe a bit surprising, right? Because if you look at the standard city, Vienna is no exception, just think about what type of people live in which part of a city. You're going to soon find out, or probably know, if you know the city already, that there are going to be some pockets of the city where you have young and cool folks living. You're going to have some other places where people are a bit more senior and sometimes posh, yet other places are populated, right? by loads of parents with children, and you kind of wonder what drives these different type of people into different parts of the city. And in this paper, we want to give an answer to that question. Eventually, I'm going to seek to convince you that to understand the rich heterogeneity of the population within the city, you need a quantitative spatial model with a lot of group heterogeneity, right? I mean, you're going to think about not just income heterogeneity, which we have been working with in these models, but we're also going to have heterogeneity by age and also heterogeneity by family types. And the big answer, I mean, to preview what we're going to find is that amenities is going to matter. It's going to turn out that the main driving force for residential sorting is actually preferences for amenities rather than preferences for commuting or, let's say, housing demands or other endogenous forces within the canonical model. I think this is very interesting from a pure economics thinking point of view, right? I mean, I think we do want to understand how people sort within cities and why. There's also an important policy dimension. Maybe that's of interest to people here at this and other research institutes, right? We are going through major demographic trends in many countries, if not all. And the big demographic trends I think of are aging population, increasing singlehood, which is a point that is a little bit underappreciated at some points, and I come back to that in reduced form, why I think actually it's an important point. And the third point is, of course, falling fertility. And if, as I'm trying to claim here, right, I mean, preferences, depending on family circumstances, depending on your stage in life, are very heterogeneous, and then we have these massive demographic trends, what you would expect is that over time, demand for locations within cities is going to change massively, and potentially, if we want to think about the long run, right, how do we want to develop cities? Where do we want to deploy infrastructure, right? We would want to know actually how the structure of demand within the city would change as we experience these demographic trends. So eventually, we're going to run some simulations. Let me show you a bit more about what we actually do in this paper, and then after this slide, I'm very happy to open the floor for an interactive discussion. It's a long presentation, so you should ask questions along the way, but let me finish this slide, just to make sure I can hammer across some points that I think are important. I mean, the first one is, you may eventually not be super excited about the empirics, and you may not be super excited about the model or even the counterfactuals, but I think it's extremely difficult not to be excited about the data set, right? I mean, this is really, I think, the stronghold of this paper. We are very proud of it. We've compiled the data set that covers actually the universe of Denmark. We decided to just work with Copenhagen because there's really just one big city, or reasonably big city in Denmark. This data set, to give you an idea, you can start thinking about it like these matched employee-employer data sets that you have in many countries. So you know where someone lives and someone works, what company they work for, right? I mean, you know the hours they work, the wage and the skill and all these kind of things, right? I mean, this would be a data set that is the backbone maybe of our data set. It's covering the universe of the population, not just workers. We also have people who don't work, people who study, pensioners, right? I mean, people who don't work at all. We can augment this data set, adding the property dimension, so we know exactly in what property someone lives. And I mean not just the building, I mean the actual flat, so we know exactly the amount of floor space consumption, right? I mean, so this person lives in a flat which is 80 square meters large, for instance, right? That's something which we don't normally observe in urban economics research. So we can compute exactly what fraction of the income someone spends on housing, which is very interesting. And then on top of that, we have the entire family tree, right? I mean, we know when people live together, right? I mean, someone meets someone and then moves to the same address. We know who your children are, who your parents are, your grandparents, I mean, you name it, right? I mean, it's a very comprehensive data set. It's the universe, and then, right, I mean, which is really beautiful, it's all of this in a panel, right? In a fully balanced panel for more than 30 years, right? So this is a pretty unique data set, which allows you to do many things. And when you can do many things, you start with doing some descriptives. I'm going to show you a little bit of the life cycle, location choices, very descriptive, and then I'm going to sort of use the panel dimension to econometrically Yeah, I'm not going to claim causality here because that's not the point, but I'm going to show you that this life cycle pattern is not driven by correlated unobservables, but it's really coming from people making different decisions. The same person deciding on a different location, right, I mean, as they progress in life. That's the point. And then eventually I'm going to discipline a quantitative spatial model to understand the mechanisms of what is driving the location choices. And the answer, as I said, is going to be amenities. And then in the final stage, if I have the time, I show you some counterfactuals, right? I give you the headline finding already in case we don't make it to the end. It's going to turn out that all of these demographic trends, aging, falling fertility, and increasing singlehood are going to have sizable impacts on the spatial distribution of the population within the city. However, they're going to work in opposite directions, so that the net effect actually is much smaller than each of the individual effects, suggesting that cities will probably prove, by and large, relatively resilient in terms of the relative structure of demand within the cities. This is taking Tokyo as a point of reference, right? I mean, what we're saying is actually that, I mean, sooner or later, developing and developed countries are approaching a state that roughly corresponds to Japan, right? I mean, in terms of population, aging, fertility, and singlehood, right? I mean, of course, you may challenge that Japan is the right reference point, and you could run simulations for any other country. Yeah, I think that's it for the initial starting point here. From now on, if you have any questions, right, I mean, just kind of raise your hands. And I should also ask you maybe until what time do I have?
We're going until 1:40. I'll give you 10 minutes beforehand if I give you a little signal.
Okay, that's actually for this paper not so long. So I should try not to be talking too much on side stories. This is a view of space on Copenhagen. This is the center of Copenhagen. Here's the airport. Typically, this is the area you would care about when you think about Copenhagen. What we actually work with is an area which is much larger than that, right? And this is only to really preempt any question about, have you actually included, I mean, the entire labor market area, right? What about adjacent municipalities? This is an area large enough so that, I don't know the exact number, but it's something like 99.9% of the population living in this area also works in the area and vice versa, right? So it's an integrated labor market, and sometimes we have smart people asking me about what's actually happening with the bridge, right? Because here we have another city, which is Malmö. And I can tell you it's about 15,000 out of 1.5 million people in our data set that commute across the bridge. So it's not a particularly important fraction of the workforce, which to me means we don't have to go through the hassle of actually adding Malmö to our data set. I mean, it's not impossible to do it, Ismir tells me, but it would be a lot of work, and I think given the small number of commuters, it's probably just not worth the effort. Okay, what else do you want to know? I mean, I told you 30 years, so the exact years are 1986 to 2019, right? Eventually, we may actually use more recent years. So far, we've been a little bit hesitant. Guess why, right? I mean, COVID, we don't really want to apply a COVID paper, but probably at some point we're going to extend the data. So far, it's 2019. The georeference we've chosen, this is all work that has to be done on a server, which sits in the Office of Statistics Denmark. The data can obviously not get in and out, right? I mean, this is all subject to great confidentiality. You have to make choices how fine the spatial detail is, because the finer it is, the bigger problems you have with your confidentiality criteria, right? I mean, you're going to be tested significantly more intensely, right? I mean, if you use exact addresses. So we are using here throughout the paper 100 by 100 meter grid cells, which I think for anything we do in this paper is really detailed enough, and it makes our life significantly easier. We have the other features of the data that I already mentioned, of course we did the usual GIS modeling, computing travel times between locations in very sophisticated ways. I don't go into details here. This is interesting. High-level stylized fact, right? Something we were thinking actually when we started to write this paper was, okay, I mean, no, different stages in life, you make location choices. There are two ways to think about it. I mean, are we interested in location choices between cities? Like, okay, I get older, now I want to live in a smaller city. Or are we interested in location choices within cities? And both can be interesting papers. The question is just, what do you start with, right? And the right panel here gives you the answer. I mean, we know this usual finding from the literature that people move a lot when they're young and much less when they are old. But then conditional on making a move, there is an 80 to 90% chance that they are moving within cities. And that is something which we not only find for Copenhagen, but also for any other city that we pick in Denmark. And this tells us that, okay, where you want to start probably is a paper that looks into location choices within the city. And then, of course, at some point, you can also write a paper. David Albu is actually working on one where you can also look at location choices across cities. Okay, but the vast majority of moves in Denmark are actually within commuting zones. Okay. Then let's look at this very descriptive graph, and let's focus on the top left graph here and on the black line. Okay, this black line that you see here is the simplest possible way of summarizing the data set that I could think of. We take the monocentric city model as kind of a reference point, like in the previous session, right? We had this kind of monocentric city paper summarizing the idea that the interesting things, particularly the jobs, are in the city center. This applies to Copenhagen, I would say. It's a pretty monocentric city. So we summarize here, right, everything in terms of distance from the CBD. These are kilometers. And then what I do is nothing else than just taking the entire data set that I have, right? This is 1.5 million people times 30 years, so something like 50 million observations. And I simply compute conditional means, right? What's the mean within the 1 year age bracket of people who are 20 years old, 21 years old, and so on and so forth. And then with this simple black line, right, immediately tells me, well, okay, people who are young tend to live in the suburbs, right? Typically because they're still living with the parents. Then when they leave the house, they move to much more central places, maybe because this is where the universities are, maybe this is because there are interesting things to do there, interesting people to meet, right? They stay there for a while, and then when they get older, well, I shouldn't say when they get older because the black line is descriptive, the older people tend to be living in the suburbs, and then there is this interesting right tail here where you see that the very old people tend to live relatively centrally. I mean, it's just kind of pick your brains. What's your first hunch when you see that, right? I mean, older people tend to live relatively central. What's your first guess why that might be the case?
They don't like to drive.
They don't like
driving.
They don't like driving, yeah. That will be, I mean, this is completely consistent with the idea that actually elderly people like to live in walkable areas, right? I mean, that was my first intuition too. It turns out, no, it's actually just a cohort effect. It's very boring, right? This pattern of life that we find them for all the cohorts. It's just that the cohorts are shifted downwards. So what happened is that Copenhagen grew significantly over time, and the people who are old now, right, when they were young and making their choices, they chose just kind of mechanically places closer to the city center, and then later on they simply stayed put. So you end up with this falling tail here, which, as you see, looking at the red dashed line, disappears in the moment when I introduce individual fixed effects in computing these conditional means. So in order to get rid of this cohort effect, right, I mean, this is the most pronounced feature of the data, but you can think of many other correlated confounders, in particular the skill of people, right, I mean, preferences, whatever, right, I mean, you can wash that out simply by adding an individual fixed effect and then getting the red line from a comparison of the same worker as this worker progresses in life. And then the red line is simply the average across all these 1.5 million workers. And here now we get the causal interpretation, right? Causal in the sense that I can say, okay, people, right? They are born in a suburb, right? They move to the city center, right? They want to be cool, and then eventually, right, once they become parents, they become just like their parents and move back to the suburbs, right? And then they stay there and nothing happens. So that's the cycle of life. A cool, I think, stylized fact that I haven't seen like that in the literature before. As you suburbanize your life, your residence in the second part of your adult life, right? I mean, well, not the second part, but once you're no longer super young, right, you also suburbanize your job. Okay. Travel times stay relatively constant, except for the first years. And then there is this constant increase in floor space consumption over time, which maps, of course, to a large extent. Simply that people get richer over time, they gain experience. And then here in the right tail, I can tell you the reason why floor space consumption goes up for the elderly is simply because the spouse dies, people don't move, right? So they then mechanically end up consuming more floor space. Okay? So that's the, I think, big picture stylized fact. I mean, that's what's going on. The next thing that I want to do is to think about how I can decompose this red line, right, into a contribution that comes from life events and a contribution that comes from age. I mean, these two things are obviously correlated, right? I mean, as you get older, at some point, many of us find a spouse. At some point, many of us have children. At some point, some of us separate, right? And the question is, how much of this age trend can we attribute to these life events? How much is it genuine age trend? I mean, it could also be that someone who doesn't experience any life event still changes locations within the city because, I mean, preferences could be simply purely age dependent, right? To separate that, we run event studies. So we consider a bunch of life events. So we look at cohabitation. Cohabitation is, let's call it the Danish version of marriage, right? It has a legal status, you're not married, right, but you're living together, and you get a bunch of also advantages in terms of taxes and so on and so forth. Then we have the life event of having children. You can separate. Empty nesting means that the last child leaves the home, you can retire, and eventually your spouse can die. These events can happen repeatedly, okay? And we will include the second cohabitation, the third cohabitation, until less than 2.5, I think, right? Yeah, less than 2.5% of the population are affected by a life event. So if less than 2.5% of the population have a fourth cohabitation, then we don't consider the fourth cohabitation because we think it's not relevant. Other than that, we put all of these events together in one event study. Okay? We're going to estimate the effect and all the leads and lags of having a child, for instance, conditional on having cohabited before, right? So when you see an event study, the way you think about it, we're changing this one life event and this one life event only, right? We are holding all the previous life events that might have led to this life event constant. Okay, you had a question?
Yeah, just very briefly, the cohabitation. I cannot just cohabitate with my roommate. It's still something like marriage.
Yes. The answer is yes. How we really can differentiate between the two, I have forgotten. I would have to ask Ismir. But the way you want to think about cohabitation is really something like, I mean, you enter a romantic relationship, right? Which for some reason the Danish government will be aware of, right? And it will show up in our life. The details at some point I have to be, I mean, I want to be transparent, right? I mean, a lot of actually the institutional knowledge is with Ismir, but I think I've understood that this is actually not just the fact that you're living together, right? I mean, students living together, being roommates, are not cohabiting, okay? Very good point. Yeah, there is a lot of technical stuff here, right? I mean, ask me later if you want to, right? About how we then make sure that we address the issue of problems with weights. We use an imputation approach that is inspired by Borussia, but we don't do exactly what they do because we do not assume parallel trends. But I think that's boring stuff, not for the keynote. Let's just look at a couple of nice graphs, right? I think this is more entertaining. So let's focus on the top left graph. I mean, this shows you the time trend on how and when people decide to change location subsequent to a cohabitation. And what you see here, I mean, I'm gonna put it, I mean, it's casually, right? I mean, so we have people, right? They enter this romantic relationship. They move to a place. When they move together, that is actually a little bit closer to the center, right? So two people, right? I mean, so some of these people choose new flats to move together, but sometimes they simply move into each other's flats. And what this graph shows you, this little dot, is that at the beginning of the relationship, they choose to live in the flat that is closer to the CBD, right? I mean, you start thinking like, okay, I mean, if we want to live together, we want to live together in an exciting place. But then something changes, right? Then soon after they move to this exciting place, somewhat closer to the CBD, they decide moving out, right? And this is not due to having children or anticipating children. This is controlled away by another event, right? So this is a genuine kind of discovery that maybe if you live together, right, I mean, you end up going out less, you sit more on the couch, you watch Netflix, right? And you feel that, okay, you know what, I mean, watching Netflix, we can do this very nicely in the suburb, right? That's the way how you want to think about it. The job doesn't change very much. Therefore, travel time increase. And I think this here is important, right? I mentioned it. I think that the whole issue about singlehood is underappreciated in the public perception. We talk a lot about housing crisis, and in Berlin, people wonder why do we actually have a housing crisis, right? I mean, we keep building properties and population grows, but not so much. We shouldn't have a housing crisis. Well, part of the issue is related to rent regulation, I think, right? But another part is this, right? When people move together, they consume in per capita terms quite a bit less floor space, right? So of course, two people together live in a bigger flat than one person alone, right? But they do not live in the flat twice as large, right, as the flats they would have occupied when they were living alone. So increasing singlehood, right, this directly follows from this graph here, right? I mean, of course, leads to an increase in floor space demand and can be one accelerator of a housing shortage.
So why should that be accelerator of housing shortage if this has always been the case?
No, because my point is that singlehood is increasing dramatically, right? We have very significant increases in singlehood in most developed countries, right? Japan is obviously at the forefront. I think they have in certain age groups they have now singlehood shares of 40–50% or something, right? And other countries are actually moving in that direction.
Okay, but how would that fit? I don't know for Copenhagen, but for Vienna, the per person consumption of housing spaces has been constant over the last 30 years. I don't know. Maybe this is different in
that's
square meter per person, which is constant. I don't know.
Is that so? Yeah, in Berlin it has been going up dramatically.
Okay.
From the 90s to today, it went up, almost doubled, and now it's going down a little bit again, right? So maybe Vienna is in that sense an interesting case that the two factors, right? I mean, economic growth and singlehood, that just offset each other in the way that you managed to keep it constant. And also my impression is that you have a much more efficient housing market than in Berlin, right? So probably you didn't have the sort of vacancies we had in Berlin before, and now you don't have quite the tension that we have in Berlin. But I think the story for many German cities at least would be that increasing singlehood puts pressure on housing markets because singles consume more floor space than couples, and we are having more and more singles in Germany for sure. In Vienna, I don't know. I mean, maybe the Austrians are sufficiently romantic, right? And they are going to the coffee houses, right, and meet each other, right? In Germany, it's definitely different. In Japan too. In Korea for sure. I mean, I think that's even worse in Korea. Okay, so let me speed up here, right? This is what happens when you have children, right? Conditional on already having moved to the suburb. When you have a child, you decide to move to the suburb even more, right? This is something which, surprise, surprise, can be anticipated, right? You know that at some point you will have a child. No reason to expect parallel trends here, right? something which is a little bit discomforting, I would say, that even in this utopia of Denmark, where you don't have something like a gender gap right before women have a child, you actually see that once they have a child, there is a significantly different response in terms of the employment location choice. You see that men stay put, they keep working in their good jobs in the CBD, but women tend to move out, they follow the suburbanization of residents with the suburbanization of the job. I mean, I suppose they take care, apparently more often than the men, of the childcare in the afternoon, and therefore want to be closer to the children in the afternoon, which is not something that you would have necessarily expected, because Denmark seems like such a progressive country, but still there's a little bit of a gender issue remaining here and surfacing in a way that I wasn't aware, right? I think it's an interesting finding if you are into that literature. Okay, so we have plenty of
excuse me.
event studies. I'm not showing.
On that one, there's been some recent research that showed when the woman is the breadwinner, the man is the one who commutes less far.
Oh, that's cool. I mean, we could definitely check that.
In other words, it's the income in a dual couple, or dual earner couple, that is the one who is more likely to live further, work
We could
further
split that
away.
further, right? We could say, okay, man, women, then we could kind of split it further by.
So you might want to look at that division.
Yeah, I wouldn't be surprised, especially in Denmark. I wouldn't actually be surprised that if it was the other way around, the head of household, right? I mean, you could get the reverse pair. On average, though, that's not the case. I think this is, I mean, I have to show it, right? I mean, you don't, so at least I, in my research, don't get the chance so often to observe reverse experiments, right? Here I do, right? I mean, I see what happens when people move together, when they cohabit, and I can actually also see what happens when they separate. And indeed, right, I mean, when you separate, right, you start feeling a little bit uncomfortable on your couch. Watching Netflix, you feel like, okay, maybe I should go to a place where I can do other things. Maybe I can go to a place where I can find another mate, right? So people move back to the city center once they separate. This happens after the first separation. It also happens after the second separation. Then it doesn't happen anymore. Right? So at some point, give up, right? But for some time, I can tell you that they still keep trying, right? I mean, going back, looking for the people, and of course, you also get back the mechanical effect here on the floor space price, which is going to be important, by the way, for our counterfactuals when we simulate the effects of having more singles in the city. Then, of course, these effects here, right, are going to be driving the results. Yeah, at old age, not much happens, right? So let's wrap this up. Let's take all these many point estimates from all these different events, put them together, and compute the joint contribution, right? I mean, so essentially, this is a cumulated effect. We can compute for each individual person in Copenhagen. We can compute the joint contribution of all the life events. And then we can say, okay, look, from the red line that you saw before, I'm going to have a joint effect that comes from the life events. And then the residual is going to be the pure age effect, right? And what this graph here tells you is that, so the joint effect of all these life events is that they are pushing you to the suburb, right? It's really the fact that you're kind of cohabiting, that you're having children that makes you move to the suburb, right? The pure age effect coming from people who experience very little or no life events, right? I mean, is that you move to the city center and you stay there. Right. It's a bit of an awkward counterfactual because it comes from, admittedly, maybe somewhat special people, right? But that's what the decomposition tells you. I think the really important punchline here is that life events and aging are quantitatively important, right? So one of the two doesn't do the trick, right? If you really want to understand location choice within cities, you want to have them both in addition to the usual income heterogeneity that we have. Okay, so not much time for the theoretical framework. What we do, we pick the good old Berlin-Born model, right, that Daniel and I worked on many years ago, and we augment it to accommodate rich heterogeneity, Okay, so we're going to have high-skilled, low-skilled people. I mean, some people have done that in the meantime. Then we're also going to have young, old, in some extensions, even the retired. And then we're also going to have different family types, right? Whether you are cohabiting or not, or whether you have children or not. And then we want to use the model to understand, okay, what is driving location choices? And the way this works is we take the model is a general equilibrium model, it accounts for residence choices, location choices, it accounts for heterogeneity in commuting preferences, in preferences for housing demand, labor demand will be heterogeneous, right? And what we're going to do is going to ask the question, okay, which of these driving forces can explain the spatial heterogeneity? And the way we ask the question is, okay, let's assume I flatten commuting preferences. Let's assume I give all the groups the same commuting preference. How much would the heterogeneity in location choices fall, right? Or, that's the most interesting, right? If I gave all people the same preference for amenity choices, or sorry, for amenity features, right? How much would that affect the spatial structure of the city? And here, what you need to understand is that in this type of spatial equilibrium models, the amenity term is simply a structural residual that follows from an indirect utility function where you have wages, rents, the prices of goods, and the commuting cost in there, right? So you take the model, you feed the model with information on wages, rents, goods prices, and so on and so forth, right? And what the model cannot explain through its endogenous mechanism, the model is going to attribute to this amenity term, right? And this amenity term, by location, will differ across all these many groups, okay?
So can I just ask, these are age group specific preferences?
Age, family type specific preferences. So a group will be defined by how old you are. Bye-bye, Gabriel. So I'm surprised because now we get to the model and he runs away, right? I mean, he's actually a good old trade modeler, right? I mean, okay. Maybe because he found out that in my gravity equation there's only commuting and no trade, right? So he thought, okay. So it's a group is defined by young, old, and these are broken down whether they are married or not married, and they are again broken down into if they have children or not. Okay. So it's a lot of groups in there, right? And we use the model to essentially back out parameters that differ across all these groups. I mean, if you have quantified such models, I mean, this is exciting. I don't think anyone has estimated, I don't know, 12 Rechet parameter or whatever, right? I mean, for the quantification of a model, and the same for commuting gravity, and the same for the production function, right? I mean, all these parameters exist 12 times. And so do the amenity values for each individual location. And yeah, now I wanted to answer, do these mechanisms that I have in mind, there are a couple of more, but let's call them commuting, housing demand, amenity preferences, do they explain the spatial sorting? And I can do this nicely and transparently here, I guess, right, with this graph. I can simply put the housing expenditure share here on the y-axis and the average distance on the x-axis. And if you look at this graph, what you can clearly see, it's not that the people who consume most housing live in the suburbs. It's the opposite, right? So it cannot be the housing expenditure share that explains the sorting. With commuting, it's even crazier, right? I mean, the people who have the greatest aversion to commuting are actually those who live in the suburb, right? So it must be something else. And yeah, I mean, what it ends up being is essentially the amenity preference, right? I mean, we've created an index here of how suburban the amenities are in a location. And what comes out is that clearly, right? I mean, the people who end up living in the groups who end up living in the suburbs are those who enjoy these suburban amenities. You can look a bit deeper. We've done a lot of effort of kind of correlating our model inverted amenities with observable amenities, and nice things come out that are completely in line with what you would expect, right? I mean, senior people, people with children, they like natural amenities, they like open space, they like parks, they like being close to the ocean, whereas young, high-skilled, right? I mean, they love being close to bars, restaurants, and this kind of stuff. Parents like school quality. I mean, it's it's the way you would expect, right? So yeah, you can actually illustrate that here on maps, right? Which is just kind of reinforcing the point. Here we have the simulation exercise where we just tell you, okay, how does the composition of people in different locations change as we flatten different primitives of the model? And again, the finding is that it's really this amenity term that is driving location decisions. And yeah, I guess with this in mind, I spent the remaining minutes that I have. I might be over time already. No?
A little bit.
Okay.
3 minutes.
So I spent the remaining time on the counterfactual. So to remind you, right, I mean, I want you to to take away a couple of things from the presentation. One really is that we want to account for age and family types in the comprehensive quantitative urban model, and what is driving heterogeneity is preferences for amenities. Okay, and now comes the next point. What does it mean for cities as we experience these demographic trends, right? We know now different population groups have strong different preferences for different type of locations within the city. Does that mean as we experience demographic change, we're going to have a big change in the spatial structure of the city? You need to make a decision on what your counterfactual is. What's the kind of city that you have in mind that we will converge to in the long run? We have opted for making Copenhagen look like Tokyo is today, right? The idea is that at some point Denmark will become more like Japan. You could also use forecasts for Copenhagen, but then it would be less interesting, I think. I mean, having this cross-sectional comparison between cities from different countries is maybe more interesting. So we collect the key fractions here, right? I mean, on singles, couples, age groups, we collect them for Japan, and then we feed them into the model. So it's a bit of an unusual counterfactual. It's not the type of counterfactual we usually do with these models. We're not changing the parameter values. We're not changing the fundamentals. We're simply changing the endowments, okay? So we pick a certain group, right? For instance, the young, we shrink it, and we increase the group of the old accordingly to keep the total number constant. And then you can see here on these maps what will happen actually in these counterfactuals. You see that as the city ages, right? I mean, the city center should die out a little bit, right? People move to the suburbs, but then the fertility counterfactual moves in the same direction because parents love to be in the suburbs, right? And now we have fewer children. This increases a strong force, right, that rejuvenates the CBD, right? I mean, you were talking about the future of CBDs, right? I mean, keep that in mind. If you have fewer children, right, of course, right? I mean, that means that the city center is going to be in greater demand. And then the singles counterfactual actually, in terms of the residential population, doesn't play out so dramatically in terms of floor space prices. It has very significant effects. I'm not going to show you the map here now because I don't have the time, but it's rather important to keep in mind that actually the singles counterfactual in terms of the affordability of the city actually delivers quite some important insights. Yeah, but then if you look at these different maps, right, and you put them on top of each other, you can already see that the effects cancel out each other, right? So we don't have the strong alarm bells ringing here. Although, I mean, as a city planner, you want to think about actually which of these three trends is the most important for your city. If you expect that one of these trends is dominating the others, right, then there may still be reason to think about your city changing significantly in the future, right? And that's it, right? I think I gave you the takeaway messages already, right? I mean, use quantitative urban models with rich heterogeneity, right? Amenities matter. They're way more important than I think appreciated so far, right? And maybe in European cities, at least, actually, we have more striking heterogeneity in location choice with respect to age and family characteristics than with respect to income, right? And yeah, with this, I stop here, right? I mean, because I want to stick to the timeline. Thank you.
we have a bit of time for some questions. First.
Thank you so much. Thank you, Gabriel. Amazing paper. Amazing data, of course. My first question is about inheritance. I guess that's an important life event, which has a sudden economic impact. So, for location choice, for the ability to move into a bigger flat.
Yeah, I can only respond to that actually in terms of what Izmir told us. It's apparently not an issue in Denmark, right? He says, I mean, we looked at that actually. We can see that. We see wealth also in the data. We can see wealth shocks, right? Wealth shocks, they're not very big, and first we thought, I mean, there must be an issue with the data, but apparently what Izmir tells me that it is much more common than in Germany for sure, right? I mean, the parents just kind of eat up all the wealth they have, right? I mean, they pay when they get older for fantastic holidays for the children, right? But they don't really kind of pass on much of an inheritance, right?
But they don't, cannot you observe when someone inherits an actual property?
Yeah, we can see when someone suddenly has a property, right? I mean, we can look at that, right? So what we could do, right? I mean, that's a good question. I will ask Izmir if when someone gets a property, whether I can check that this correlates with some cash transfer they got before, right? Yeah, that's an interesting idea. Maybe this is a way to actually isolate that parents kind of, yeah, I mean,
You can also observe whether people move to the property of their parents, for example.
yeah, that doesn't happen, actually. That doesn't happen. I mean, that we checked. But I mean, the idea that they could somehow get money to buy a property,
Yeah.
that's interesting. I mean, this could happen, yeah. Yeah, good point.
Jim?
Gabriel, thank you very much. This is very impressive, and I'm jealous that you have such wonderful data to access. A couple of perspectives from something less ambitious that we've done for Chicago. Looking at the general equilibrium properties of the process of aging, one thing that has become very clear is that as the population ages, there's an increasing spatial separation of the source of income and the place where it is expended. So as our population becomes over 65, an increasing share is non-wage and salary income, so it's pensions. Mm-hmm. And so the connection between the job and expenditures is increasingly becoming separated as our population ages. And I think that's an interesting dynamic. The second thing is that, in contrast to Europe, Americans are not forward-thinking, and as a result, a lot of people retired and then discovered that they were healthy enough that they were going to live beyond their pensions or their savings. So one thing we've seen is an amazing reattachment to the labor force of people over 65. And that has an interesting location implication. Are they going back to the same jobs that they had before and in the same locations? And what we're finding is that the share of wage and salary income of people over 65 has actually been growing over time. So that's an additional dynamic to something you've looked at. And then looking at the structure of interdependency between these age groups, what we've discovered is over the last 30 years is that the indirect effects of expenditures are increasingly concentrated in the higher population groups. So what we've seen is income inequality is increasing between age groups as a result of this dynamic. And partly that can be explained by the fact that the consumption of older populations is different from the people age 50 to 64. So the income dynamics would be very interesting. I hope you have a chance to explore this, because I would be very interested to see whether the outcomes are very, very similar. So basically, aging is increasing inequality within metropolitan areas in the U.S. Thank you again.
But I mean, this last point is very interesting. Is that a mechanical in the sense that differences in income are more pronounced among the older groups than the young groups? Because just we kind of accumulate experience over time, so we end up actually with bigger wage differences among the older than the young. I think this we have in the counterfactual, because the way these simulations run is that we change the the endowment, but then our older population has the higher productivity than the younger population, right? So unless there is something like an on-top income inequality, right? I mean, some endogenous force, we would probably have that already in the model, but it's good to think through actually how this might be a driving force in the counterfactuals. And I love what you just told me about how older people optimize in the US. And in Copenhagen, unfortunately, it's just utterly boring, right? I mean, these people get old, they stay put, they don't move, they don't re-enter the labor market, they just don't do anything, right? I mean, it would be a lot more interesting if we had the data, I guess, to do that kind of analysis for this population group in Chicago, right? I mean, thanks for informing me about these cool trends.
Yeah, sure. Go ahead.
No, quick comment or question. Very impressive, and the data, of course, is really cool. I was thinking whether, let's say, the time span that you're looking at, whether we can expect that also amenities would change over time and cater to the group, so that the effects that you have in your simulations might be a bit of an overestimate, so to say.
Yeah, that's a super interesting question. I mean, we inverted the amenities in 5 years intervals, right? So we can show you the structure of amenities every 5 years, but they're super constant. I mean, amenities are incredibly persistent. I mean, we were kind of contemplating whether we would go through the hassle of thinking about endogenous amenities. And this is a nightmare, right? Because endogenous amenities mean potential multiplicity. Now you can convexify models to make the equilibrium unique, but with 12 different groups, honestly, I think that uniqueness, it will be extremely difficult to achieve under parameterizations that you get from observable data, right? What reassures me that maybe we don't need endogenous amenities is that these amenity terms are so constant over time. So Copenhagen didn't experience a big change in the last 30 years in terms of the relative attractiveness of different places, the different groups, right? Unlike the urban myth of huge gentrification stories that one could picture, right? I mean, that doesn't seem to be a feature of Copenhagen. So so we checked that, right? But the short answer is that amenities are incredibly persistent in Copenhagen. This might not be an externally valid result of. This could be different in other cities.
And also, if you extrapolate into the future when these big demographic trends hold, like
yeah, no, I agree. I mean, in principle, you could say that maybe our counterfactuals in that sense, they are underestimating potential changes that could happen to the structure. I mean, the most obvious example would be parents, right? If then you end up with all type of parents being in the same areas where you have the schools, then this could be an amplifier, right? I mean, yeah, I agree. So in principle, you could think about heterogeneity of amenities. It's not a nice thing to deal with in a model with many groups. I mean, that I can tell you.
Just one quick
last question.
Yeah, one quick, yeah. A question.
You have one too.
Your issues were, everything is a static model, right? Even though we see these lines, it's static. So things like movers are more likely to move is not something you could bother considering. It's not a point. I just want to make sure.
No, that's a very good point. So, so indeed, I'm concerned really about the cross-section of the city, right? I mean, I want to know where people are living and why, right? I'm not concerned in this paper, at least, right? I mean, about the dynamic problem, right, of thinking about, okay, should I make the investment into a move, right? Then you need a dynamic model where people make an investment decision, overcoming a migration cost, and only if the incentive to migrate is big enough, then you would kind of move to a different place in the city.
And different people have different perceptions of the cost of moving. So this is
yes. But we are not there yet, right? I mean, we have some dynamic spatial models. We don't really have sufficiently rich and tractable dynamic urban models to answer these kind of questions in where you have choices at the workplace and the residential side, but people are working on it, right? I mean, Andrei Patumenko is working on that. We have a paper with Steve Redding and others, also Copenhagen, where we work on that, right? So the dynamic angle is exciting, right? I mean, but it's also complicated. I mean, it's not you have to make a lot of assumptions to keep the model tractable, right? I mean, but yes, I agree. So this is...
And getting to what Jeff said, I think you probably do count for it, which is that people who are highly educated tend to marry highly educated people, so their income potential at marriage increases inequality. And I think that's quite kind of, but you probably capture that, I think.
Yeah. I guess that we should probably have, because we have these different types, right? And they are calibrated on data. I think this potentially would capture mechanically. Yeah, good point about dynamics. I take it.
So thank you very much, Gabriel.